Alright, so today we're going to take a look at our first unit, starting the second part of the class, which is on trigonometry. Okay, so what I like to do first is just kind of look at the word, break it down, and see if we can identify some parts of that word and figure out what they mean. Is there any part of that word that people recognize, either because it's from like another word or some prefix or suffix that you know?
Yeah. Try for triangle.
Okay, so what does try mean?
Three.
So try, means three. Anything else there that people recognize? Yeah?
Matrix.
Matrix? Yeah, what's matrix?
The meaning of it by stuff from like geometry.
Yeah, so that's another subject that ends in the same thing, matrix.
So maybe like the study of.
Ology is the study of, like biology or psychology. Yeah.
It has to do with shapes.
There is another thing there that has to do with shapes, but not matrix. Does matrix kind of look like another word that you might recognize? Metric. And what's metric? What's metric? What's that? Yeah?
Measuring?
It's a system of measurement, yeah. So metric means measurement. And what about gone? That means something too. Yeah?
Does it mean like shapes?
Something about the shape. Everybody knows what it is?
The sides?
Sides, right? Hexagon, octagon, 6-sided, 8-sided. So gone means sided. So essentially, trigonometry, if you break the word down, it means measuring shapes with 3 sides. So measuring triangles. And most people don't recognize this, but a trigon is another name for a triangle. In geometry, there's a name for every shape that ends in gon. With triangles, we don't use the shape that ends in gon. Okay, that's trigon. You can. Most people don't say it that way, but triangle is how we say it. Same with 4-sided shapes. A lot of people just say quadrilaterals. You can also say tetragon. Okay, tetragons is the same as quadrilaterals. For pretty much every other shape I can think of after 4 sides, we use the gon. Pentagon, hexagon, septagon, octagon, things like that. Right? But that's essentially what we're doing, measuring triangles. All right, so what do we do in measuring triangles? Well, here's an example. Let's say that we had, let's just say like a boat. There's our boat. Okay, out in the ocean somewhere. And we have two towers that can see where the boat is. Okay, so let's say we had a tower on land over here and another tower over here. And maybe the boat, they're lost, for whatever reason, the GPS isn't working. It's cloudy, so they can't see any stars. Maybe it's even foggy. It's awful. They can't see anything. So they don't know exactly where they are, but they got a really powerful light on their boat. So maybe they can turn that light on and maybe somebody can see them, even though they can't see. Whatever. So if 2 different people can see the same object, they can figure out where that object is. If only one person can see an object, you can know the direction of the object, but you can't figure out how far away it is. Like if you just saw a light really far away, you wouldn't be able to tell if it's 20 miles or 10 miles. You can't figure that part out. But with 2, you can. And the way this kind of works is you'd have to know how far apart those 2 observers are. Now, if those were stations, like Coast Guard stations, that would be something you could just look up on a map, like looking up the distance between 2 cities. All right? So that we could figure out. The other thing you need is for each observer to tell you what direction they see the boat in. So usually that would be like a compass heading. So maybe this station on the left can see the light on top of the boat and the compass heading is like 40 degrees east of north. Okay, so it's roughly northeast kind of direction. Now, the second station can see the boat, but they're not looking in the same direction. They're not going to look northeast and see the boat over there. They're going to look more north, maybe like 10 or 15 degrees west of north. Okay, that's the direction they see. And the idea is when two observers see the same thing, now you can triangulate what they're looking at. So now you end up with a triangle right here. And if you want to figure out exactly where the boat is, it just becomes a matter of figuring out the lengths of the sides in that triangle. The bottom side you'd know. And these other two angles you would know. But you can't use Pythagorean theorem because that only works on certain kinds of triangles. So you know what kind of triangles that works on? Yeah?
Right triangle.
Yeah, it only works on right triangles. So this is a little more complicated of a problem. We're going to learn in a few weeks how we would figure it out. But that's basically the idea. Okay, so that's called triangulation. GPS kind of does the same thing like with the cell phone towers. If you're in range of multiple cell phone towers, then the cell phone company can ping your location, like if they were asked to by police or first responder. And because multiple towers are in range, it's kind of like multiple observers that can see you. And they can pinpoint, maybe not exactly where you are, but they may be able to pinpoint like a small area where you are. You know, maybe like, by a couple hundred feet by a couple hundred feet. So if they were looking for you because something happened, that might be a small enough area where they could probably find you. You know. Any question on that? All right. All right, so now we'll take a look at the first section, which really isn't trig. It's more of a review of square roots. And just to make sure you remember how we simplify square roots when they're in the bottom of a denominator, and how you reduce them, like square root of 20. So one formula that we can use that is related to trig and gets at the idea of square roots is the distance formula. So generally, the distance formula is used when you have two coordinates and you're trying to find the distance between them. Okay, when we talk about finding the distance, we're talking about on a flat surface. Okay, Euclidean distance between 2 points. We are not talking about finding distance like between here and, say, London. That's not exactly a straight line. It's more of an arc. We're talking about on a flat surface. All right, so let's take a look at this picture. All right, so I've got 2 points, okay, A and B, and I want to find out how far apart they are. Okay, so what I want to figure out is this. Well, what we're going to do with that is something we do a lot in trig. We're going to turn that into a certain shape. And then we're going to measure that shape somehow. So based on that line I drew, does anyone have an idea of something else I can draw? And it'll make a certain shape here. Yep.
You can draw a straight line just from B down to the axis. To make
Yeah. Just put in a straight line, just like that. So what shape did we just create?
Triangle.
Even more specific?
A right
A
triangle.
right triangle. So now there's some things we can do with right triangles that you can't do in like that problem with both, because there wasn't a right angle. All right, so we just created a right triangle right there. And the goal is going to be to figure out the length of the longest side in that triangle. What is the longest side? Yeah.
Hypotenuse.
It's called the hypotenuse. So essentially, you're going to solve for the hypotenuse of the triangle. And that's the distance formula. First thing I'm going to need to figure that out is the distance from here to there. Now, is that distance along the x-axis or the y-axis? It's along the x. So all I need to do is figure out where do I start on the x, where do I stop on the x, and then we just have to do something with those two numbers. So where does this point start on the x-axis?
A.
Well, the point is A, but what's the part of the coordinate that tells you where it starts?
X1.
x1.
Okay.
So we start at x1, and where is that's the stopping point on the x-axis. Where's that point?
X2.
That's at x2. This doesn't have anything to do with the y's yet. And if you want to find the distance between x1 and x2, like let's say you started at 2 and you stopped at 10, how would you find the distance between x1 and x2?
Subtracting x1 from x2.
Yeah, you subtract them. So the distance on that side of the triangle is x2 minus x1. Now, you might wonder, why are we finding the length of the bottom? We want the hypotenuse. Well, the problem with the hypotenuse is it's on an angle. Right? The base is in a perfectly straight line horizontal, and that's easy to find the distance. Anything horizontal or vertical we can work with. Something on an angle, not as easy. Okay, so that's the length of the bottom side. Now, let's look at the height. That's the highest, and it goes down to there. What's the highest that the height of the triangle goes?
Y2.
It goes up to y2. And what's the lowest it goes? y1. And now if I want to find the distance between y2 and y1, what would I do with them?
Subtract.
Subtract. Yep. So y2 minus y1. That's the height. Now we've got the base. We got that side. And we got the height. I think we said it earlier, but what's the name of the theorem you can use if you know the base and the height to find the hypotenuse?
Pythagorean theorem.
Yep, we can use the Pythagorean theorem. Okay, what's the formula for the Pythagorean theorem when you write it in just single letters? Yeah.
Is it a squared plus b squared equals c squared?
A squared plus b squared equals c squared. And what letter are we really trying to find in this problem?
C.
We're trying to find C. And we know this. And we know that. A is x2 minus x1. And B is y2 minus y1. So all we're going to do is rewrite the Pythagorean theorem, filling in the formula for the two sides that we know. So let me write that up. Let me put this back on so we can see both. Okay, so the first thing I did is I changed A to x2 minus x1. And you square it. B is the height of the triangle, which is y2 minus y1, and you square it. You add those two things together. And now, why did I put this square root here over the whole thing? Yeah.
Because c is squared as well, so you get a basic answer, so you need to square root the other side as well.
Right. I'm trying to get this. I'm trying to get the c by itself. So to get c by itself, I need to take the square root of both sides. And that's exactly what that formula is. That's the Pythagorean theorem. Just written in terms of using coordinates instead of using the A, B, and C. So any question on the Pythagorean theorem? Or the distance formula? Same thing. All right, let's try an example. So I want to find the distance between the points 4, 5 and 3, 2. Now, once you have this formula, you don't really need to draw out any kind of diagram. You just need to label which one is which, and then just fill them in. Okay. Let's start with the 4. Well, we have a choice. What could we label the 4 as?
X1.
Could be x1 or it could be
X2.
x2. Okay, right now it could be either one. Let's just call it x1 since it's the first one. Now we don't have any choices. 5 has to be what?
Y1.
Has to be y1. And the 3?
X2.
X2. And the 2? Perfect. So find the distance between those points. All right, so let's try it. So fill in everything to that formula up above. What I usually do is write out the whole thing first. So now I don't have to think about the formula, I just have to fill into it. All right, Cam, what's going to go in the first spot?
3.
Yep, 3.
Minus 4.
And then minus x1, which is 4. All right. And Alex, how about the second spot?
Sorry.
The second spots.
I don't know.
Alex, can you help him out?
It is 3 minus 5. Or 2 minus 5.
So yeah, it's going to be 2 minus 5. Okay, so that's the base of the triangle. That's the height of the triangle. And now we're going to find the hypotenuse using Pythagorean here. Okay, so Isaiah, 3 minus 4 gives me how much?
-1.
So that's negative 1 squared.
1.
Yep, so we'll square that and get 1 in a second.
Okay.
How about 2 minus 5?
-3.
That's negative 3 squared. So now when we simplify it, negative 1 squared you just said was 1.
Yep.
What's negative 3 squared?
9.
And 1 plus 9?
10.
10. So if they want an exact answer for the problem, that's how you leave it, square root of 10. If they want a decimal, well, just type in square root of 10. So it's about 3.16. Okay, any questions on that? That's finding the distance between 2 points. And this one can't be simplified. Okay, when you square root of 10, that's as simple as you can make it. The next one we're going to do can be simplified. So we'll do the distance, and then we'll see if we can simplify it. Okay, so find the distance between the points 2, 6 and 4, 10. Set everything up. Now I just have to think about what goes where. Can anyone tell me what would go in the first set of parentheses?
4 minus 2.
Yep, we could do 4 minus 2. So x2 minus x1. And the second parentheses?
10 minus 6.
10 minus 6. All right, let's start to work on that. How about, Christian, what's 4 minus 2?
2.
And yeah, let's just stop with that. So 2 squared. And 10 minus 6? 4 squared. Okay, 2 to the second power gives me
4.
4. And 4 to the second power?
16.
All right. So we get the square root of 20. Any questions just up to that stuff? Okay. Now, the square root of 20 can be simplified. Okay. Does anybody know what it would simplify to?
2 to the square root of 5.
2 times the square root of 5. Yeah.
5.
So I'm going to show you one way you can do that. If you have a way that you already know, like you figured out somehow, then you can do it however you know. Question? No? All right, so we're going to come back to that. So just leave a little bit of space to finish that off. And let me show you how you do it. So we got square root of 20, but that can be simplified. So the way that I simplify square root of 20 is I try to break it down into two numbers that multiply to give me 20. But one of them has to be a perfect square. So remember, perfect square is something you could take the square root of easily and get a nice answer. 4, 9, 16, 25, and so on. So I'm going to try to break down the number 20. So it's a product of two numbers, and one of them you can take the square root of in your head. So how could we break down 20 into something times something? And there's a lot of ways. I mean, you could do 40 times a half. That's not going to help though. Something times something, and one of them is a perfect square.
4 times 5.
4 times 5. So basically what we're going to start with is this. We just break up 20 into 4 times 5. And then the rule for square roots, when you have a product under a square root, you can separate it into two roots, just like this. So a product, it's like you can apply the square root separately to each number. Now you cannot do that with addition or subtraction, but multiplication, you definitely can do that. Right. Now, the second step, well, actually I kind of already did part of the second step. Break it into two roots, so that was part of the second step. And then simplify what you can. Which one of these numbers can you simplify easily in your head?
4.
Yeah, what's the square root of 4?
2.
2. There you go. So that's 2 square roots of 5. We'll skip number 3. We just did that one. I just changed it to square root of 32. So you want to find two numbers that multiply to give you 32. One of them has to be something you can take the square root of. And preferably the biggest number you can find. If you don't find the biggest one, it's okay. We just might have to do this breaking down more than once then. So can anybody think of two numbers that multiply to give me 32?
4 and 8.
Okay, so we can do 4 and 8. Yeah. Because 4 times 8 is 32. And what's the square root of 4?
2.
2. So now we get 2 times the square root of 8. But square root of 8 can be broken down again. If you can break it down again, it just means you didn't find the biggest number originally. So we'll come back and see if there was a bigger number. But let's continue with what we have. How can you break down 8?
4 times 2.
4 times 2. So 2. That 2 is just going to stay there. And then 4 times square root of 4 times square root of 2 is square root of 8. And what's square root of 4 again?
2.
Times 2?
4.
So 4. And what's left next to it?
2.
The square root of 2. Now 2 is a prime number, so you definitely can't simplify that. Now, does anybody see how we could have done, so this is one way, but another way we could have broken up 32, and this number kind of gives you a hint at what it would have been, because this is what you would have gotten when you took the square root of this number. Yep.
16 and 2.
Yep.
16 and 2. So if you break it up into 16 times 2, now you take the square root of 16, and and you're done in one step. They're both correct. You can do it either way. Sometimes if you have a really big number, it helps to break it up step by step. Any question on that? All right, I think I got maybe one more of those. Square root of 48. Again, this is one that there are multiple ways to do it. If we can, I'd like to find the biggest perfect square that goes into 48. If you can't, you can use a small one, and we'll do it twice. But does anyone see the biggest perfect square that goes into 48?
12 and 4.
You can do 12 and 4.
But I kind of. There's also 24 and 2.
Yeah, so those aren't perfect squares, though. Not saying you can't maybe do this a different way. Some people make like a tree and do it that way. For my method, 24 and 2 won't help us. Yeah.
3 and 16.
Well, you can do 3 and 16. Is there one bigger? Oh, no, I think that's it, actually. 3 and 16. Yeah. So, yes, you can do 3 and 16, and that would be perfect. So let's do that. 16 times 3 is 48. And what's the square root of 16? 4. Okay, nothing wrong with 12 and 4. That also works. It's just that works faster. Right, that was really the point of me going over the distance formula, just because it's an application that ties directly into a triangle, Pythagorean theorem, and it gets at simplifying square roots. Any question on that? All right, so that's the first formula for today. Right, and the second one is going to be the midpoint formula. Yeah. Yep, just say no. So let's draw it out and see if we can kind of come up with a way. Actually, maybe I just go back to the diagram we had the first time and see if we can figure out how to find a midpoint. Did I delete the diagram? No, it's right here. Okay, so midpoint, a little different. Try to find where that red dot would be. It's equidistant from each endpoint. Well, let's look at something simpler first and then see if we can figure out the one that's slanted. Let's say you wanted to find the middle of this. Where does that line segment on the bottom start?
said the segment, the little dot.
Yeah, the blue line segment on the bottom. Where is the leftmost point of that blue line segment?
It's X1.
It's at x1. And what about the right?
X2.
It's at x2. So you know where it starts and you know where it stops. How would you find out exactly what the middle is if you know where something starts and stops? Yeah?
Subtract. Divide.
By 2.
Divide by 2.
So do what? Say it again?
Divide by 2.
Add them together, divide by 2.
Add them together and divide by 2, right?
Yeah, I forgot what about it.
Yeah.
Sorry.
So like, if this one starts at 2 and it ends at 10, what's exactly in the middle? 6. 2 plus 10 is 12. And then divide by 2, you get 6. Now, there's a name for that. If you take two numbers and add them together and divide by 2, what does that give you? Yeah?
The mean.
The mean, yeah, the average. That's what the midpoint formula really is. You take your x's and you average them together, and that gives you the middle for the x's. You take the y's, you add them together, divide by 2, gives you the average for the y's. And then if you take that number for the x, that number for the y, and write them as a coordinate, it'll give you exactly where that point is. Because you got the middle here. And you got the middle right there. And that's all that the midpoint formula is. It's an average. Okay, so based on that, what do you think the formula is going to be for finding the x value for the midpoint? Yeah.
x1 plus 2 divided by 2.
Yeah, x1 plus x2, and then divided by 2. So that's the formula to find the x value. How about the formula for the y value?
y2 plus y1 divided by 2.
Yeah, it doesn't matter the order you add them in, because when you add, it's the same thing. So y1 plus y2, and then divide by 2.
Give me a drink.
Yeah. So looking at the formula, your final answer is not just a number. It's two numbers with a comma. So what do we call that?
Coordinate.
It's a coordinate, right? Midpoint gives you a location versus something like distance formula. That's not a location. Square root of 10.
Just gives you the length.
It just gives you a length. Okay, so there's a difference what kind of answer you get. One is a length, one is a location. All right, so let's find the midpoint between those two coordinates. So you got 3, 4, and 7, 13. Okay, so there's your kind of like the template you're going to plug into. What's going to go in the numerator of the first fraction? 3 plus 7. Now, big difference here, and some people mix this up. When you're doing the midpoint formula, there's an addition. When you do the arithmetic, when you're doing the distance formula, there's some subtractions. So you just want to remember each formula correctly. Okay, so we got that. And what about the numerator of second fraction?
4 plus 13.
4 plus 13. Okay, and now let's simplify it. 3 plus 7, and then divide by 2.
5.
That's 5. And 4 plus 13.
17.
So 17, and then divided by 2.
8.5.
Yeah, so you could put 8.5. You might see it on a test as 17 over 2, but you could see it either way. Any question on that? So finding the midpoint, pretty straightforward. Now, what if you wanted to find? Let me just draw it out. Let me take this one. So that's the midpoint. I don't think that's quite big enough. So let's take, actually, because I got to go to 13. So let's take background. Does that go to 13? 7, 8, 9. No. All right, we'll use this one. I'll go to 13. All right, and I'm going to erase it so you can see it a little easier. But we had the points 3, 4, and 7, 13. Okay. All right, so 3, 4. 3, 1, 2, 3, 1, 2, 3, 4. And 7, 13. So 1, 2, 3, 4, 5, 6, 7, 5, 10, 11, 12, 13. Each red line is 5. So, all right, so there's our line segment. and we just found the coordinate of the midpoint. And what was it?
It was 5, 8, 5.
So 5 and then 6, 7, 8.5. Looks like it would be right about there. Looks perfect. It's probably a little hard to see, but all right. Now, instead of the midpoint, what if I said I wanted the quarter points? How would you figure out, instead of dividing the line segment into 2 pieces, which is a midpoint, how would you divide it into 4 pieces, which would give you the quarter points?
Would you just divide by 4?
Let's see, take your coordinate, add them up, and divide by 4.
Yeah.
Let's try it and see what happens. Let's try it down here. So if we add them up and divide by 4, that would give you 10 over 4. And then that would give you 17 over 4. If we did that. So now when we write this out, let's just do some decimals. So 10 divided by 4, that's 5 divided by 2. So that'd be 2.5. And 17 divided by 4 is 4 1/4. Let's see if that looks reasonable. 2 1/2, 4 1/4. Okay, so go right 2 1/2. 1, 2 1/2. So now I'm here. And then up 1, 2, 3, 4 1/4. So it puts me right about there. That's 2 1/2, 4 1/4. What do we think? Did that work?
No, but
No. So it's a good thought, divide by 4. That didn't quite work, yeah?
Might be a lot of work, but you could take the new, it's like X, that first point on the bottom, and then the midpoint, you could take those and then add those up, divide by 2, and then add the midpoint to the other point, do the same thing, add those up, divide by 2.
Yep.
Find the midpoint of each.
So yeah, you could just find the midpoint again and find the midpoint again. And that would give you the quarter points. Or we can try to be clever and figure out, basically, using a triangle, how far over and up do you go to get to that green dot? And then do half that. All right? So to get to the green dot, how far over do we go?
2.
So we go over 2 and up 1, 2, 3, 4 1/2. Okay, so now let me move this out of the way so we can see it better. What's half of 2?
1.
So let's go over 1. And what's half of 4 1/2?
2.25.
Okay, so 2.25. So let's go over 1 and up 2.25. Over 1 and up 1, 2, and then just a little bit more. What do you think? Does that look like it?
yeah.
Yeah. So we can figure it out that way too. And we could figure out exactly what that coordinate is if we wanted. It's it's 4, comma, and that was 5, 6 1/4. So that's up 6 1/4 right there. Graph paper makes it easier to figure out. Okay, so any number of segments that you want to find that is a multiple of, I want to say multiple, power of 2, I think you could do pretty easily. So you could cut it in half, 4 pieces, 8 pieces, 16 pieces. It'd be a little harder to maybe figure out in between that. Like what if you wanted to cut it into thirds? Well, the approach I would take to do that would be more involving how far over and how far up. Okay, but we're not going to get into that right now. Okay, any question on that? All right, so that's all I really wanted to take a look at for the first day. Okay, just the distance and midpoint. Nice. So you've got plenty of time. You can start the homework. Okay, 15 to 21 is the distance. 39 to 43 is midpoint. And then there's 4 square root problems to try. If you finish all the square root problems, well, actually, if you finish everything, you can show me. You've got about 30 minutes or so probably enough time to finish that. Just to be clear, there won't be this much time at the end of every trig lesson. Yeah. Not all the time.
I was hoping.
The first one's a little bit shorter, and then after that it's a little bit more regular.